Okay, graphing rational functions is week 8, lesson 3, I believe. Yes, it is. Okay, so I would like to start by just showing you some pictures of the types of graphs that you are going to be producing after this lesson, okay? So rational functions tend to have asymptotes to them based on parts of their equations. Okay, so this one has 2 asymptotes. In fact, there's one right here, right? You can see that dotted line. And that's a vertical asymptote. And then here's another, this is a horizontal asymptote. Okay, this is kind of cool. This one has a vertical asymptote. Wrong color. There we go. It has a vertical asymptote and it has a slant asymptote. Okay. This one, okay, this doesn't have an asymptote, but it has what's called a hole. Okay, it's literally a hole in the graph. Okay, this one, check this out. This has 2 verticals, right? 2 verticals and 1 horizontal. And usually, okay, I want to say like 99% of the time, you will not be crossing any horizontal asymptotes, but it is actually possible. I want you to take a look right here. Okay, notice that this graph does cross the horizontal asymptote. If it happens, it can only happen once. Okay, you won't have multiple crossings of horizontal asymptotes, and it tends to happen near the origin. Okay, so again, something new, something different. You did not see those last year. Okay, this one also 2 horizontal. Oh my gosh, what is wrong with me? 2 vertical, 1 horizontal. Okay, I want you to see that you can have a graph that is a parabola with a hole in it. They won't always necessarily be lines. So again, we're taking what you learned last year, because you did learn how to do this last year, and we're just sort of making it, pre-calculus honors level, right? We're building on what you learned last year. This chart that you're going to see on the next slide right here, this chart is on the worksheet that you are going to be doing, so you can always refer to it. I'm not going to read it to you. You can read for yourself. I will tell you one thing, though. The order that you're I don't want to say required, but the best order to do this in is to do holes first. Okay? Always look for holes first, because if you have a hole, it's going to change the rest of these answers. Okay, the other thing is that horizontal and slant, these 2 together, you can have one or you can have the other, but you'll never have both. Okay, so when you're checking for those, if you've got horizontal, you're guaranteed not to have a slant, and vice versa. All right, so let me scoot this up. We're going to kind of talk you through one of these from beginning to end. All right, if you have that paper that has all the descriptions on it nearby, that's probably a good idea. Let's take a look. We're going to check for holes first. Okay, now to check for holes, you have to check if this function is factorable. Okay, and this one is not, which means there aren't any holes. Okay, next you're going to check for, and again, I tend to check these 2 at the same time, because both of these are dependent on the degree of the top compared to the degree of the bottom. Okay, now the degree of the top is 1. It's the highest exponent that you can find. And the degree of the bottom is also a 1. So when that happens, you're looking at the leading coefficients. In other words, the number that's here, which is a 1, over the number here, which is a 1. So this one has a horizontal asymptote of y equals 1, which automatically means that there is no slant asymptote. All right, next. And I'm going to kind of erase some of the stuff just so that it's not quite as cluttered. Okay. Next, you're going to check for vertical asymptotes. Okay, vertical asymptotes are all dependent on the denominator. What makes it 0, which in this case is x equals 3. The y-intercept you get by plugging in x equals 0. So when you plug in x equals 0 into that function, you end up with 0 over -3, which equals 0. Okay, the 0 you get by looking in the numerator. All right, what makes that numerator equal 0? And it is 0. The domain and the range, I won't answer this part until I actually have the graph. So what I'm going to do right now is I'm going to transfer this information that I just wrote down onto the graph and see if we can get a better picture. So let's go ahead and start with this vertical asymptote at x equals 3, which is here. And the horizontal asymptote of y equals 1, that would be there. And then the only other thing I can transfer is the y-intercept, which is this ordered pair. Okay, so now I need some more ordered pairs, right? I don't know where to draw this thing. So I'm going to make a little XY chart. In fact, I'm going to switch colors, I think. I'm going to make a little XY chart. And the minimum number of dots that I want you to graph is 2 per section. Now, I'm going to grab a highlighter really quick. A section is going to be defined by where the vertical asymptotes are. So this section is to the left of this vertical asymptote. I need 2 ordered pairs there. I already have 1. So I'm going to go ahead and just pick another x value to try, like, oh, maybe 1. Wrong color. 1. If I plug 1 into the function, I get 1 over -2, or -1/2. 1, -1. So here's an extra dot. Okay, now believe it or not, with just that, I can draw the graph over on the left of the vertical asymptote, because asymptotes act like magnets. Okay, they draw the line towards them, so you can see my line is getting closer and closer and closer to the asymptotes, while at the same time not crossing them and going through those 2 dots. Okay, now let me see if I can do this. I don't know if it's going to let me. Oh, nice. Okay. Now, I also need some dots on this side of the vertical asymptote, right? Over on this side, I need some dots. So I'm going to pick some x values, right? Like 4, 4, and 5, right? Those are on x values that are to the right of that vertical asymptote. If I plug in 4, I think I get 4. And if I plug in 5, I get 5 halves. So let me plot those dots. 4, 4, 1, 2 is here. And 5 halves, that's 2.5. So 1, 2.5 is right here. And then I can draw this line in. Okay, and again, that works because your asymptotes act as magnets, and your line has to go through the dots you just drew. Okay, so there's your first rational function. Okay, let me scoot this up. Let's try another one. Okay, so first question, or the first thing I would like to fill in on this chart is, are there any holes? Okay, and this one doesn't have any holes because the top doesn't factor. Okay, so I'm just going to go ahead and write in none. Next, I check for horizontal or slant. This one has a slant, all right? And the reason is that the degree of the top is a 2 and the degree of the bottom is a 1, okay? When you have the top exactly 1 more than that of the bottom, you have to do long division. Okay, so let me do some long division to get the slant asymptote, which also automatically means that there is no horizontal. All right, so x goes into x squared x times, then you multiply, and you subtract, and you bring down. Now I need x to go into -3x, which goes -3 times. I multiply, and then I subtract, and I bring down. Now you get to ignore the remainder. So the slant asymptote here is x minus 3. Okay, next, the vertical asymptote is dependent on the denominator. What makes that equal 0? The y-intercept I get by letting x equal 0, which doesn't work, right? If I try to plug in x equals 0, I get something that is undefined. So there is no y-intercept. Okay, the zeros are based on the numerator. In other words, what would make the numerator equal 0? So let me see. X squared minus 3x plus 5 equals 0. Man, it would be nice if that factored, but it doesn't. So the way to solve that is with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and hopefully you can see right now that this comes out to be a negative, right? It ends up being 9 minus 20, which means those x values would be imaginary, which means there aren't any zeros. You know what I just realized? I did not do the domain and range on the last problem because I was going to draw the graph and go back and do that. So let me do that really quick and I'll come back to this problem. Okay, so for this picture, now that I've got an accurate graph, the domain goes from negative infinity, non-inclusive, to that vertical asymptote of 3, and then it starts back up at 3 and goes to infinity. And then the range, starting way, way down at the bottom, goes from negative infinity to positive 1, and then picks up at 1 and goes to infinity. Okay, sorry about that. I should have done that earlier. And maybe I'll put it back together again, not sure. Okay, finishing this one. In other words, drawing the picture and then putting the answer in. All right, so here we go. Hold on, I need to move this down just a touch. Okay, and see if I can get rid of some stuff so it's not in the way. Okay. All right, so let me put in what I know. I know x equals 0, which is going to be this vertical line. This asymptote at negative, slant asymptote, 1, 2, 3, with a slope of 1. Okay, so this dotted line is going to count as my asymptote. Okay, and then I don't have any dots. Okay, so I'm going to make an XY chart that goes to the left of this vertical asymptote. I'm going to make a different XY chart that goes to the right. Okay, so if I plug negative 2 in, I get negative 7.5. If I plug negative 1 in, I get negative 9. By the way, you guys, I'm not doing that really, really fast in my head, okay? I have this on my paper. You are more than welcome to grab your calculator and plug the numbers in, right? You're trying to plug them here into the equation to see what comes out, okay? Now, when I plug in 1, I get 3, and when I plug in 2, I get 1.5. So let me plot those points. Negative 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe that's 9, which makes this 7.5. So here's what this picture looks like over here. And then 1, 3 is here, and 2, 1.5 is here. So this is going to look like that. Okay. And I'm sorry this all got erased. I'll put it back in for you really quick. None, y equals x minus 3, none, none. Okay, the domain goes from negative infinity to the vertical asymptote of 0. And then it starts back up at 0 and goes to infinity. And this is one where you can't say what the range is without any level of certainty. And the reason is, until you get to calculus, you're probably not going to know how low this goes or how high this goes. All right, so I won't be asking you range questions on ones where it's impossible to answer like this, okay? Just know you won't be asked that. Okay, so let's try this to be my last example. Okay, so on this one, again, you always check for holes first, which means does this factor, which it does. Okay, and hopefully you can see that this, not that, this and this are going to cancel. Okay, they will. Now, before you cancel, okay, look at the blue highlighted parts and ask yourself what x value makes that equal 0. And I think you will say it is -2. Okay, again, it's highlighted in blue. I've got my x value in blue as -2. Now, this is where this is really, really, really important. I would like you to cancel those, right? Cancel them, cancel them, cancel them. But not only that, cancel out the original function. I don't even want you looking at it anymore. It doesn't exist anymore. All that exists, all that is left now of your function is this. Okay? So I hope when you look at that, you know, hey, that's a line. That's a line. I can graph that line right now if I want to. But first, before you do that, let's figure out the second part of the whole. Okay, if you take that -2 and plug it in here, you get -4. Let me plot that. -2, 1, 2, 3, 4. This is the whole. Okay, it's a whole. That's all it is. It's just an open circle. It means that the function doesn't exist there. Now, let's graph this line. That line has an intercept of -2 and a slope of 1. Okay, so again, you can kind of see, I'm going to try to freehand this. My straight lines tend to be really horrible, and I apologize for that. But it's a line with a hole in it. Okay, that's what this picture is. So now, if you're looking at that picture, does it have a vertical asymptote? No. Does it have a horizontal asymptote? No. Does it have a slant asymptote? No. Does it have a y-intercept? Well, yes, it does. It's right here at 0, -2. Does it have a 0? Yes, it does. Right there at 2, 0. Okay, what's the domain? What are all the x values? Well, there's a whole bunch of them, except for right here, right? So it goes from -infinity up to the 2, non-inclusive, and then it starts back up at 2, sorry, I should say -2. And it goes from -2 to infinity. Okay, and then the range, if you look at this from the y direction, right, it's coming this direction. It goes from -infinity to -4, and then non-inclusive. Non-inclusive. Oh, and this one, sorry, I screwed this one up. That should be non-inclusive. There we go. Union with -4 to infinity.